Welcome, welcome. All right, we are getting deep into trigonometry. Lesson number 6. Why call it tangent? We have the so, we have the ka, now we have the toa, the tangent. This will be opposite over adjacent. What does that all mean geometrically on the unit circle? We need to understand. So let's look at the first part. It says let P is this point here. Remember, if you have the initial ray and you have the terminal ray, what do? You put a point over here and drop it down. That P, that initial point you use is called x subscript theta, y subscript theta. So whenever you see something here on the bottom right of a number or a variable, we call it subscript. So let this be the point where the terminal ray intersects the unit circle. So this terminal ray intersects the unit circle after rotating theta degrees as shown in the diagram below. Using triangle trigonometry, what are the values of x of theta and y subscript theta, okay, in terms of theta? So what does that mean? It's a lot of mumbo jumbo, but let's look at this part over here. Let's try and break whatever this is down a little bit. If I were to say, let's have our triangle, right? Let's say we have our circle. This is what our initial ray, right? And this is our terminal ray. How do we find sine of theta, sine of 30 degrees and cosine of 30 degrees? What do? You make this point, and then let's call this point P, right? Let's call that point P, and then what do? We just drop this down, and then by now we should be very good with the triangle. If this is 30 degrees, right? This is what? This is a half. This is what? This is 60 degrees. This is 90. What do we have? The 30, 60, 90 triangle. This is a half. This is square root of 3 over 2. And this is 1, right? So sine of 30 degrees is a half. And cosine of 30 degrees is the adjacent, which is square root of 3 over 2. But one thing we need to realize is that this point here, this P, right? What is the position of this? Like if I were to say what point is this? This is 1, 0. What is this one? This is 0, 1. This is 0, negative 1. And this is negative 1, 0. We know where these points are, right? But if I say what's this point, now we do know what this point is. The x value and the y value, right? This is an x value, the 1, and this is the y value, 0. We know what this point is on the unit circle. It is using these two. Here, from now on, we're going to say cosine of theta will represent x value. And we're going to say sine of theta represents the y value. Because if you think about it, cosine of theta is what? Is this distance, right? This is cosine theta. It's the x value. The sine of theta is the y value. So this has a point, and this point is square root of 3 over 2 comma 1/2. Okay? That is the position of this point. And if you're saying, Mister, how, like, why don't I have 1, 2, 3? Like, we're not getting whole numbers. We're getting an irrational number and a rational number. It's very weird. But I know this point is square root of 3 over 2 comma 1/2. Okay? So we need to get into this idea of what it means to be an x and y value. So let's move on, right? Here, how do we do this problem, right? If it's 120, what do? We just put this point over here, right? And then we drop down the perpendicular line. And then if this is 120, this has to be 60 degrees, right? This is 90, this is 30. So then we use the 60, 30, 90 triangle, right? So then what's the distance from here to here? This is square root of 3 over 2, and this is a half. But remember, we're on this side, so cosine of 120 will be negative a half, and the sine will be positive square root of 3 over 2, right? Oh, sorry. It'll be positive square root of 3 over 2. But we know this point now, that this point, let this point be P. This P is negative a half, comma, square root of 3 over 2, right? That is the position of this point. But what I could also say is that this position of this point is also P cosine of 120 degrees and sine of 120 degrees, right? I'm just substituting. What is cosine of 120 degrees? It's negative a half, so I put it here. What's sine of 120 degrees? It's square root of 3 over 2. I put it here. So you're allowed to say that this point is cosine theta, whatever theta is, and sine theta, whatever theta is. Okay? And that's what this part is saying over here, that if we have, using triangle trigonometry, what are the values of x, oh sorry, I keep mispronouncing, x subscript theta, y subscript theta, right? What are the values of x subscript theta and y subscript theta? It's basically x of theta is equal to cosine of theta, and y of theta is equal to sine of theta. Okay? That's what it's saying here, that these two values are. Okay? Now here it says, using triangle trigonometry, what is the value of tan theta? Well, from now on, tangent theta will be opposite over adjacent. So now we know this is the opposite over adjacent, right? So this is just equal to, what is our opposite? Here it's y theta. Oops, sorry. Y theta and x of theta. But basically, tan theta is equal to sine of theta over cosine theta. Okay? And that's it. This is a very key important thing. This is just to get a mathematical understanding of what's going on with tan theta. And geometrically what it means, we're going to go through the whole thing. What I'd like you to do for this part here, let's take a look. This part, it's talking about the definition of tangent theta. And if you were to read this, it is pretty confusing to read at first. But what I'd like you to do is copy these mini questions down, right? It says copy this down, and then copy these deeper understanding questions, and then we're going to go over it together. Okay? So pause the video and copy this and copy that, right? Okay, so let's look at this. Let's try and answer this. Which part of the triangle is sine theta? Remember, sine of theta, right? Sine of theta over here represents this height. Remember? Sine of theta is up, down. Cosine theta is left, right. So if I say which part of this triangle does sine of, which part of the triangle does sine of theta represent? It's going to be this part over here, PQ. Okay? PQ will represent sine of theta. Okay? And what will represent cosine theta? It'll be this point, OQ. This is the position O, and that's the point Q. It's this part of the triangle. This is cosine theta, so it's OQ. OQ. Okay? Okay, so let's continue on. So here it says tan of theta is equal to sine theta over cosine theta, right? Because remember, if this is theta, right, what is our opposite over adjacent? Our opposite is the sine theta, and what's our adjacent? It's the cosine theta. So this is true. This is tan theta. It's sine over cosine. But it says, if we look at this definition over here, it says, in terms of sine and cosine functions, tan theta is equal to sine of theta over cosine theta for cosine theta not equal to 0, right? Cosine of theta cannot equal 0. And my question is, why? Why can't cosine theta equal 0? And I think we could all answer this, because if you have sine theta over 0, this is undefined. We're not allowed to have cosine theta be 0. So this is undefined. Next question, for what values of theta is cosine theta equal to 0? When does cosine theta equal 0? And if we look in this triangle, if we look in the circle, when is cosine theta equal to 0? I want you to pause the video and think about it, and raise your hand if you need help understanding why. But it'll be this position here and this position here. Because in the other videos, remember, what's this point? It's 0, -1, and this is 0, 1. And look, you see our x value is cosine theta. So for some xy, this is the cosine theta, which is 0, and this is 0. So here, cosine of theta will equal 0 when theta is at 90 degrees or 270 degrees. Okay? So when theta is equal to 90 degrees or 270 degrees. Okay? So basically, if you're trying to find if cosine of theta is equal to, if you have cosine of 90 or cosine of 270 on the bottom, that's not possible. Okay? And what about this? For what values of tan theta is tan theta undefined? Well, that's just, whenever you can't have tan of 90 degrees, or you can't have tan of 270 degrees. These two are not possible. You can't do it. All right? Now, this idea of tangents will take some time for us to understand, but for calculations wise, what we could do is, let's see what happens when we start plugging in numbers, right? Here it says for each value theta in the table below, so these are our theta values. Remember, these are the degrees of rotation. Here we have negative rotation, so it's going clockwise, and this is going counterclockwise. Use the given values to find sine theta and cosine theta to approximate tan theta to 2 decimal places. So what I'd like you to do is, with your calculator, right? Let's first, let's reset calculator. Let me shut the light off. That's a little better. No glare. Okay. Let's see. So second memory, 7, all RAM, reset, right? So we reset the calculator. And now what we need to do before we do anything is we need to go to math. Oh no, not math. We need to go to mode. Mode. So go to mode, and then you see here where it says radian and degree, we need to go to degree, okay? And then we hit enter, right? And notice that the degree is popping up. So what I'd like you to do is let's go second quit, right? And now let's approximate tan theta. So let's plug in this. If I put in tangent over here, and I put in negative 89.9, I get negative 572.95. Here it's saying approximate to 2 decimal places, so we could just write negative 572.96. Okay? What about the next one? Let's clear. What's tan of negative 89? Hit enter, and we get negative 57.29, right? And what I'd like you to do is just go all the way down and then see what happens. And then we're going to answer this part over here. Okay? I'm going to pause the video and write them down myself. Should have gotten when you put in tan of negative 89.9 degrees and so on and so on. So let's answer these questions here. And this will be extremely, extremely difficult, this idea and concept, because it's a very high level math. So here it's saying as theta approaches negative 90 degrees. So that's how you read it. As theta approaches 90 degrees. And theta is greater than negative 90 degrees, what is the value, what does sine of theta approach? So here, let's think about it two ways. Imagine you're here on the circle, right? Is it hard to see? Let me shade it in a little bit. Okay. Okay. Let's imagine you're here, right? From here, if this is 0 degrees rotation, right? This is 0 degrees rotation. Actually, let me put a different color. If this is 0 degrees rotation, it's saying, imagine you're here and you go theta is 0 degrees right now, right? Right now we're 0, okay? We're here. If I were to go negative 90 degrees, which way am I going? I'm going this way, right? This is negative 90 degrees. I'm going here. So it's saying here, as you go negative 90 degrees this way, what's the value of sine of theta over here, and what's the value of cosine theta? Well, here, our sine of theta is going to what value? Remember, every xy position, this is cosine theta, sine theta. Here, our sine theta is going to -1, and our cosine theta is going to 0. Okay? So that's what this question is saying over here. It's saying, as theta approaches negative 90 degrees, what is the value of sine theta approach? It's -1. And here, as theta is going to negative 90 degrees this way, what's the value of the cosine theta? It's approaching 0. So the thing is, if you were to take tan of theta as it's approaching 90 degrees, which is what this question is saying here, imagine what do you think the tan value of this will be? It'll be tangent, it'll be -1 divided by 0, and it is undefined, but it approaches negative infinity, okay? And this concept is very difficult to understand. And what I'll do is I'll show you something with the calculator to maybe help us understand this a little more. Let's look at the next one. It's saying as theta approaches 90 degrees. So if I were to go 90 degrees this way, right? 90 degrees this way, where do I go? I go to positive 90 degrees. And what's my position? It's 0, 1. So if my position is 0, 1, then my cosine theta is equal to 0, and my sine of theta is equal to 1, right? So here it's saying as theta approaches 90 degrees, sine of theta approaches +1. As theta approaches 90 degrees, cosine theta approaches 0. So then what's happening if I do sine of theta divided by cosine theta? What happens if I do 1 divided by 0? It is undefined, but it is going to the positive infinity side. Because don't you remember this end behavior concept that we talked about a long time ago? Okay. And here it's saying what's the range of the tangent function, and that is any number between negative infinity to positive infinity of all real numbers. Okay, you're in this set. And this looks like a lot of mumbo jumbo, and you're thinking, Mr. G, what on earth are you doing with me right now? So let's try and take a picture. Let's see something. What I'd like you to do first is just clear the calculator, right? Let's reset calculator, okay? And I'll show you something, and I'll show you what does the graph of tan theta, what does it look like? So let's find out. So we have all the RAM cleared. Hold on 1 second. Okie dokie. Okay, this looks good. Here, let's do this. Let's go y equals, let's just put in tangent theta, right, and close it. And what I want you to do is hit zoom, and let's go z trig. And now watch what happens with tan theta. It has a very, very weird behavior. Just watch. See how it goes up, then down, up, then down, up, then down. Okay? And the reason why it's doing this is because here, you see how when I talked about how it goes to negative infinity, it's because as it's going up, it goes down to negative infinity. And then as you do another rotation, it goes to positive infinity and then go back down to negative infinity. Then up to positive infinity, then down to negative infinity. And it just keeps going up and down and up and down. every 180-degree rotation. This is happening. Okay, I think I did a good job of confusing you. This is not easy, but with time, this idea of tan theta will become more clear. What it means geometrically with respect to the unit circle as a triangle, we're going to learn together. Okay.